Okay, welcome. Today we're going to learn about graphing a system of inequalities. We're going to have a few different graphs with us today, like a linear function, absolute value, parabolas, all the fun ones. Okay, so first when we are graphing these, our first step that we kind of want to take here, when I'm graphing a system of inequalities, realize first of all it's not a system of equations. We have our inequality symbols here. So when you see the inequality symbols, you should be thinking graphing. Obviously. You should be thinking shading. Okay? So we'll get to that in a second. The steps I like to follow. First step, I like to graph each inequality. Should you write that down, all of this. Then I like to determine the shading. And then finally, some people do this in the beginning, but I determine if the line is solid or dashed. I like to have a step for it because otherwise I usually forget, but yeah, you can do it in the beginning too, that's fine. Okay, so first let's graph each inequality. I'm going to call this number 1. Okay, I see that this is a linear function with a y-intercept of 2, and then the slope is 1. So I'm going to go up 1 over 1. You can keep following that. Get a more accurate graph. Okay, something like that. Just kind of go through that, but oh well, it's okay. It's not. Go. Yeah. Okay, there we go. Okay, now my second graph, second inequality here, is an absolute value inequality. Well, with my absolute value inequalities, I need to find my vertex. Remember, it's opposite what we think here, so it's -4 and then -3. So it's going to be my lowest point. And then we see our slope. We look at the number that's kind of in front of x here, out front of our absolute value, and we see here that's just going to be a 1. So I go to my vertex, -4, 1, 2, 3. Okay? And then I see my slope is 1. So I'm going to go up 1 over 1, up 1 over 1. I think these two lines are actually parallel to each other. And then the same thing here. What's kind of important to make sure we do draw accurate graphs. These are kind of parallel. Okay, there we go. Okay. Okay. Step 1 is done. We graphed each inequality. Life is good. Now we can determine the shading. Okay? Looking at the pink one here, well, remember the pink one was a linear line. We're looking at all the y values that are greater than that line. Well, the y values that are greater than the line are the ones that go up here. So I'm going to be shading this way with the pink line. Then when you look at the blue line, we're looking at the y values that are less than that blue line. Okay? So I see all this stuff here, and I'm looking at the y values that are going to be less than that. And that includes these two. Okay. And now we're looking for when the two graphs overlap each other. Well, if you see all the purple or the pink goes up here, the blue comes down here. And if we look over here, kind of draw this out a little bit, we have the purple that comes up here too, and that's where the blue comes down. So our answer is actually the area over here, in between those two lines there. That's the area where both our blue and our purple intersect or overlap the shadings. And the final thing we need to do is determine if the line is dashed or solid. For the purple line, it could be equal to, so those answers are part of our solution. So that's going to stay solid. This does not have the equal to, so our absolute value needs to be dashed. Just write that, that's fine. If you want to actually dash it and erase it, that works too. Okay, so again, this is our solution set to this system of inequalities here. Okay. Great question. Mr. Pons, what does this mean? The nice thing about this solution set right here is if you were to pick any ordered pair that falls in the orange here, those are the only ones that'll work for both of these at the same time. That's the key. These ordered pairs make both of these true at the same time. Okay, we could try one more example here. See if I can actually save the graph. Usually it's a pain. Maybe not too bad. Okay, it wasn't as bad as I thought it'd be. Okay, the system that we're going to look at next will have y, and keep it consistent, have purple be the first one. Y is less than x squared plus 4. Actually, you know what? I had minus 4 because it doesn't really honestly matter. And x is greater than. Okay, so step one, I want to graph each of these separately. So for the first one, okay, we see that's a parabola. So if I look down here, my vertex, it's pretty much as x minus 0. So my vertex is 0, comma, -4. It's a lot of review how to graph those. And then we want to have a point of accuracy. When x equals 1, this is just another point, so we're a little bit more accurate with our graph. Y equals 1 squared minus 4. Y equals -3. So my point of accuracy be 1, -3. Okay, so 0, -4, 1, 2, 3, 4. Okay, 1, -3, 1, 2, 3. And then we could use symmetry to get the second point here. There you go, something like that. Use other points to make it more accurate. The next one we have here is actually, this crosses. Slacking, need to be more accurate. This crosses right there. Okay. Our second point, or our second inequality we have, x is greater than or equal to 2. So a lot of us struggle with these. One way to kind of think about it is, what's the line where all your x values are equal to 2? Well, if we think about it, here, if we were to have a vertical line here, all our x values there are equal to 2. The y values change, but all the x values are equal to 2. So x is greater than 2, that's going to be a line. Right there. Okay, now we have to determine the shading. Well, we're looking for the y values that are less than our answer here. The y values that are less are the ones that come down here. So my shading is going to be all that stuff outside of here, so everything except for what's in the parabola. And then I'm looking for the x values that are greater than 2. Okay, well now I'm looking at my x values that are greater than 2, while the x values that are greater than 2 are this way, 3, 4, 5. So I'm going to shade this way. Here. And now we're looking for when the two graphs overlap. And if you can kind of see here, you'd be drawing down with the purple and to the right with the blue. So I'm going to extend this out a little bit and show. And remember, drawing down. So my answer is going to be everything in the orange here. Okay? This is everything that is kind of lower than the purple and to the right of our blue linear line. Okay, final thing we need to do is determine if the line is solid or dashed. Well, for the purple, there's no equal to, so the parabola needs to be dashed because those solutions are not included. And then that vertical line is solid, so we can keep that, is equal to, so we can keep that solid. And again, you should be thinking to yourself, what does that orange shaded region actually mean? And these are just the ordered pairs that make both of these inequalities true. Okay? None of these ordered pairs work, just the ordered pairs that are in the orange make those two inequalities true. Hopefully that makes a little bit more sense. Like I said, follow the 3 steps you have here and then try to understand what your answer means at the end, and you should be good to go. You might see a few systems of inequalities where you have 4 or 5 of these. That's okay. Just take it one step at a time and see where their overlapping area is or the overlapping shading, because that's going to be the solution set that works for both of those.